Now for this example, when I go through and I do this, and if I start off just by putting these points on here, 5, -3, and -1, 2, I can get this vector that looks like this. And that's a fine vector. But normally when we do this stuff, we don't like to have vectors just out and about on the plane wherever. So I take and I move this. And I always move it so that it starts at the origin. So I get something that looks like that. And if I call this vector v, what I'm going to do is I'm going to put this into this form here with these brackets, and it goes to the left 6, so that's a -6, and it goes up 5, so that's a 5. And once I have that, well, then I can go through and I'll just use my couple of formulas to find the magnitude. So it's the square root, and it'll be the square root of that -6 squared plus that 5 squared. And I'll have 36 and 25 and add those together, and I get the square root of 61. And then I will use the tangent of 5 over -6 to find the angle. Now this is where you have to be a little bit careful with things, because when I go through and I do the inverse tangent of -5 over 6, and I put that into my calculator, that gives me a -39.8. But that is not the right angle. If you were to put down that this is square root of 61 at -39.8 degrees, I'd mark that wrong on a test or quiz, because that's not the angle this is at. This angle goes from here, starting at the positive x-axis, rotates around to there. So that 39.8, that's the reference angle right here. That's not what I want for my answer. What I have to do to get my answer is to take 180 minus that 39.8 to find what this angle here is in particular, and I have square root of 61 at 140.2 degrees. So be careful with that. Make sure you're using the angle that goes with the appropriate quadrant.